We condensed the parallels into 3 individuals, which were in series, put those together, then took this last parallel, combined it to 3.5, used the 7 volts to get 2 amps coming out of the battery. But I used the loop rule first, right away, to get 1 amp coming out of that, or through this resistor. That lets me know that this coming down and this going back up is 1 amp, right? I have 1 amp coming through here, 1 amp coming through there. So that lets me know that this is 0.5 and 0.5, or half an amp each. Now, here, what has to be true about the current? Yeah, this one has to have twice as much current as that one. So this is going to be 0.67 amps. This is going to be 0.33 amps. I just did that in my head, right? If you're not sure, you can think of it like this. If this is I, this is going to be 2I, and then that means I plus 2I equals 1 amp. Right? And that means 3I equals 1 amp. I is 1/3 of an amp, which is that. Okay? Now this one, how many times bigger is 12 than 4? 3 times bigger. So if I do that, this is I. That means this is 3I. So that means 4I equals 1 amp. That becomes 0.25 amps, and this becomes 0.75 amps. And now that I have all the currents, I could find the power at any place, right? By using I squared R. So I can find the power consumed by any. So which bulb is the brightest? If these are all bulbs, which one's the brightest? Yeah, the 7. Because it has 1 amp of current. Does that make sense? So this is going to be I squared R. So this is going to be 7 watts of power being used right there. If you go to these, this becomes 0.025, right? No, 0.25. So 0.25, this is going to be 1 watt. This is 1 watt. Right? This is a huge resistance, but when you square this, you get 0.125. So then it's some really. Okay, questions? All right, so then let's do something similar. So let's go make this, these are all going to be in microfarads. So let's make this one 3, make that one 9, make this one 4, make this one 2. And then we can make this one 1, and this one 5, and then we can make this one, so whatever, okay, we just need the weird numbers. And then this one will be 8. And then make this 10 volts. It's going to be ugly, but whatever. So, go. I want to know the charge on every capacitor. Or do you want 10 over here? So then let's make this 12 volts. So since this is recording and I didn't pause it, if you don't want to see it, don't look. Okay, so here, the 3 and the 9, they're parallel, so I just add them. Because it's capacitors. Parallel, just add them. These two are in series, so I do 1 over 12 plus 1 over 6, which is 2 over 12, which gives me 3 over 12, which inverted gives me 4. These are parallel, so I add them, and so I have 12 volts and 12 microfarads of charge. So I have to use C is Q over V, or Q is CV. Q is CV. So that means I have 144 microcoulombs of charge that are connected directly to the battery. So how many things are directly connected to the battery? Or yeah, if we look here, here, and here, we can see all of these are connected directly, and then the backs of these are all connected directly. So you see that these are all going to have the same amount of charge through here. So if I go back up to here, I can see that this is 8 and 4. Right? Do you get what I'm saying? These two, well, technically these 4 capacitors combined down into this 4. That means this one is going to have twice the charge of that. And if I look at 144, how do I divide that into thirds? 48? Yeah, okay. So this is going to have 48 microcoulombs, and this is going to have 96 microcoulombs. So there are 96 microcoulombs of charge here, and then there's going to be 48 spread out over these. This is 3 times as much as this. So this is going to have 3 times, this will be 12 microcoulombs, and this will be 36 microcoulombs. And then down here, this is twice as much as this, so this will be 16 microcoulombs, and this will be 32 microcoulombs. Okay?
Wait, isn't it like
48? Is that it? Yeah, 48. Okay. Because the bigger capacitor has more charge.
if they're both 48, doesn't that make it so there's like, or is the capacitance like the same throughout?
Well, the total capacitance comes out to be this, but how the capacitance breaks down is just a function of where you're looking at it in the system.
So it's not like 24, 24 then?
No, because these two still add, like, so you get Catherine's question? It's a good one. If you look at this, this is, Kathleen, sorry. If you look at this, I insulted you and praised you at the same time. This is 12 and this is 6. She's saying this is a bigger capacitance than this. Why do they have the same charge? Because they're in series. And when capacitors are in series, it's weird. Right? That's why you inverse. See, do these have the same capacitance? No. But they have different amounts of charge. Yes. Because they were in series, we had to adjust. And then hopefully if we did the voltage, it would all come out to the same thing. Yeah. See, if you follow the loop rule, right, then this should be 12 volts. And V is Q over C. So 96 divided by 8 is 12. And if you divide this, 12 divided by 3 is 4. And if, well, yeah, if you go through, yeah. All right, so